Hello students, let us see the derivative of inverse functions today. Let y is equal to fx be a function. The inverse of y is equal to fx is given as x is equal to f inverse of y. Now, y is equal to fx has an inverse if and only if a particular condition is obeyed. That is, if and only if y is equal to fx is a 1, 1 and onto function. Now, what is a 1, 1 and onto function? This you have learned in your last year itself. I'll give you an example. Suppose y is equal to 3x minus 4. In any relation between y and x, say, you know that every element of y, every value of y is called as image of x. And every value x is called the pre-image of y. This is from your set theory of last year actually. Now, suppose we represent the values of x. Suppose we take x as 1, 2, 3 and 4 like given in this particular set x. The corresponding values of y, what are they going to be? You can put x as 1 in the first case in the given relation. And you will get y is equal to 3 into 1 minus 4. Thus, y comes out as minus 1. If you put x as 2, it comes out as 3 into 2 minus 4. That is, the answer comes as 2. So, y becomes 2 then. Similarly, you can find out by putting x is equal to 3 or 4. The answers for y come out as 5 and 8 respectively. Now, as you can see over here, if you write the relation, you can say that 1 is related to minus 1, 2 to 2, 3 is related to 5 and 4 is related to 8. Thus, every element of set x has at the most one distinct image in set y. So, we can say that this means that it is a 1, 1 function. Each element of x is related to at least one separate image in y. Similarly, every element of y is the image of at least one element in x. Therefore, it can be called as an onto function. So, we can say that y is equal to 3x minus 4 is a 1, 1 and onto function. So, the inverse of y is equal to 3x minus 4 exists, and that inverse is x is equal to y plus 4 upon 3. This is the concept of inverse actually. Now, what is the derivative of the inverse of a function? Let us define what is the inverse of a function or what is the derivative of the inverse of a function. If y is equal to fx is a differentiable function of x such that the inverse function, that is x is equal to f inverse y, exists, then x is a differentiable function of y. So, we can say that dx upon dy, the derivative of x with respect to y, is equal to 1 upon dy by dx, as long as dy by dx is not equal to 0. So, in this way we find the derivative of the inverse function of y. Now, in the exercise, the first type of question, find the rate of change of demand, that is x, of a commodity with respect to its price, that is y. In the first sum, y is given as the function 12 plus 10x plus 25x square. Now, in all the sums, the procedure is going to be the same. That is, after writing y, we differentiate both the sides with respect to x. That is, we find dy by dx. So, in this case, dy by dx comes out to be, now the derivative of 12, see the function y. The derivative of 12 is 0 because 12 is a constant. The derivative of 10 into x is 10 into 1 because ddx of x is 1. So, the answer comes out to be 10. And the derivative of 25x square, it is 25 into 2x because x square can be solved by using the formula x raised to n. So, the answer, simplifying the answer, it comes out to be 10 plus 50x for dy by dx. Now, we have to find dx upon dy over here. So, we find dx upon dy by using the formula 1 upon dy by dx. Thus, we get the rate of change of demand with respect to price as a reciprocal of our answer for dy by dx. That is, it comes out to be 1 upon 50x plus 10. So, this comes out to be dx upon dy. The second question, that is y is equal to 25x plus log 1 plus x square. Before finding the derivative of the function, observe that log x is not given there, but log 1 plus x square is given, which means it's a function inside a function, that is a composite function. Last lecture, we had gone through how to find the derivative of composite functions. So over here, while differentiating both the sides with respect to x, we consider this way, that is dy by dx is equal to. Now 25x is simple enough. The derivative of it is just 25. What about log 1 plus x square? We use the outside inside rule over here, as I taught you last time. That is, we first find the log derivative of the log function, and then we find the derivative of whatever is inside the bracket, the derivative of that particular function, that is it. So as a result, we get 1 upon 1 plus x square, because log 1 plus x square, the derivative of that is 1 upon 1 plus x square, into again the derivative of 1 plus x square by using the chain rule. So here we get 25 plus 1 upon 1 plus x square into 2x, because the derivative of 1 plus x square, 1 becomes 0 and x square becomes 2x. Thus we simplify and get the answer for dy by dx. Over here in the last step, observe that we have cross multiplied and made the denominator equal, so that we can do the further step that is there. Again, the rate of change of demand with respect to price is given as a reciprocal of dy by dx. That is, it becomes dx upon dy. So we get dx upon dy is equal to 1 upon 25 into 1 plus x square plus 2x upon 1 plus x square. That reciprocal is taken up actually. The fraction, the denominator of the fraction is made the reciprocal in order to bring it up. And thus we get 1 plus x square upon 25 into 1 plus x square plus 2x as the answer over here. If you understand it, it becomes simple enough actually. Now these three sums can be done just like the previous sums as an assignment. Everywhere you have to find the rate of change. The next question, find the marginal demand of a commodity where demand is x and price is y. The first one, y is equal to x into e raised to minus x plus 7. Now what is marginal demand? From last year's data again, marginal demand is nothing but rate of change of demand with respect to price. So over here it is again the same thing, that is dx upon dy. So we have to find out dx upon dy in the end. We begin by finding dy by dx. Observe that the first function given here, the first expression over here in the function is in the form of u into v. So you are going to use product rule while finding the differentiation. That is u differentiation of v plus v differentiation of u. That is a rule that you are going to use over here. So dy by dx, that is differentiating both the sides, we get x into differentiation of e raised to minus x plus e raised to minus x into differentiation of x. Now where did the 7 go? Remember, derivative of a constant is 0. So 7 has already become 0 in dy by dx. In the next step, again, now we observe that e raised to minus x is a composite function. So we use the inside outside rule. That is, we first find the derivative of e raised to minus x and then find the derivative of minus x by using the chain rule over here. So thus we get x into e raised to minus x, again the derivative of minus x plus e raised to minus x into derivative of x is 1. So thus it becomes only e raised to minus x in the next step. Then in the next step, now the derivative of minus x is minus 1. So thus we put a minus sign in the beginning and remaining answer remains the same. We simplify it by taking e raised to minus x common. Inside the bracket we get minus x plus 1. So thus marginal demand is a reciprocal of dy by dx over here. So we find dx upon dy by doing 1 upon dy by dx. That is taking the reciprocal of our answer for dy by dx. Thus we get 1 upon e raised to minus x into minus x plus 1. Now e raised to x can be written, e raised to minus x can be written in the numerator as e raised to x. So we get e raised to x upon 1 minus x as the answer for marginal demand. In the next sum, it is y is equal to x plus 2 upon x square plus 1. You find that y is of the form u upon v. So while solving, we'll use a rule for quotient for differentiation actually. That is, if y is equal to u upon v, then dy by dx is equal to v du by dx minus u dv by dx upon v square. So thus, upon finding dy by dx, we write the denominator into the differentiation of the numerator minus numerator into the differentiation of denominator like I have written over here upon the denominator the whole square. In the next step, now x square plus 1, that is the denominator, is written as it is initially. What is the differentiation of x plus 2? X becomes 1 and 2 becomes 0. So thus into 1. So x square plus 1 remains as it is. Minus x plus 2 into. X plus 2 is a numerator. Numerator into differentiation of denominator. Denominator is x square plus 1. What is the differentiation of x square plus 1? X square becomes 2x and 1 becomes 0. Thus we get the expression x plus 2 into 2x. Simplifying further, that is opening the bracket etc., we get x square plus 1 minus 2x square multiplying x by 2x. Again minus, because minus into plus is minus. 2 into 2x becomes 4x. Then dy by dx. Simplifying one step further, x square minus 2x square becomes minus x square. That's the expression. Now to find the marginal demand, we simply do dx upon dy. That is the reciprocal of dy by dx. And we find the reciprocal of our answer for dy by dx, which becomes the answer here. The next sum, again y is equal to 5x plus 9 upon 2x minus 10. As you can see, u upon v. So again we use the quotient rule. So we find dy by dx like so. You can observe the steps for yourself. We simplify it in this way. And thus we get dy by dx. Again for marginal demand, we take the reciprocal of dy by dx, that is dx upon dy we get, and we take the reciprocal of our answer for dy by dx. And thus we get the final answer for marginal demand. This sum can be done by you as an assignment in your notebook. Now this concept, if you have understood the previous lectures as to how to do differentiation, then this concept should be very easy for you. You should be able to solve these sums in a very small time actually. Now you keep practicing and write all these sums whichever have been given as assignment as well as whichever have been given solved in the video in your notebooks. So in the next lecture we will go to the next concept. Till then, stay safe and healthy students. Bye.